Hello everyone, good morning. Is I audible?
Yes, sir.
Is I okay? Yesterday, actually, again, someone asking this problem. What is on your screen right now? Okay, something is there on your screen. That question yesterday. Okay, J advanced question paper. Therefore, again, I will discuss. Okay, some other way. Okay, okay, but from now onwards, you will not confuse. But listen. Acha, in this one, how much you got? Approximately 495 something, na? Only few students send this year. You should send at least when I say at least one time. Only I can say first time I have say ki send something you did not send. Okay, so here approximately I think 495 mega electron volt something you will get here in this question. Now on that when your screen, okay, one problem is there that I will discuss. Okay, and after that, inshallah, you will not confuse. Okay, listen how to solve this kind of problems. I told yesterday also, but okay, no problem. Listen. See, see, everyone know 2 pi r is equals to n lambda. Okay, but even though some students may confuse, sir, how you got this one? We already discussed, but again I will say, okay, because it was a long time before I told. 2 pi r equals to n lambda. How? See, everyone remember mvr is equals to nh upon 2 pi. Yes or no? Yes. So MV are equals to NH upon 2 pi. And one more thing you know, lambda is equals to H by MV. So from MV, what we can replace? So MV here I can write MV is equals to H by lambda. Put at this place here H by lambda into R is equals to NH upon 2 pi R naught. Yes or no? Okay, so here HH will get cancelled. So 2 pi r is equals to n lambda or not? Yes, you got. It means whatever this n, how you got this n? N we got from here. This was what? This was orbit. What was orbit? The first orbit, second orbit, third orbit, fourth orbit, fifth orbit. What is this? Okay. Now listen everyone very carefully. Okay. See everyone. If I said to you, please suppose that everyone remember, okay, atomic structure. What I told you, R equals to 0.53 approx 0.529 something. Okay, so 0.53 n square by z, and that was in angstrom. You forgot or not? Forgot, na?
No, sir.
Acha, you not forget. Okay, I thought you should forget. Okay, so R equals to 0.53 n square by z angstrom. This everyone remember. Acha, ठीक है, accepted. Now listen everyone very carefully. I want to put at this place. See, so 2 pi R is how in any orbit I want to talk. So suppose that 0.53 into n square by z angstrom, remember unit, okay, is equals to n lambda. So one n, this n will get cancelled. Yes. So it means final what I can write 2 pi r into 0.53 n by z equals to lambda. Have you any confusion till now? No. Now listen. It means suppose that for hydrogen atom z is 1. If I said to you, please suppose that if for n equals to 1, for if I said to you, please see everyone very carefully. It is very important thing. From now onwards, I think you will not confuse also. Okay. So if I say I already discussed, but okay, no. Now listen. N equals to 1, suppose that, and suppose that we are talking for Z equals to 1, hydrogen atom. We can take any atom, but suppose that right now I am talking for hydrogen atom. In this one, what will happen? Listen very carefully. So if I say in this is means what? Ground state. So lambda in ground state will be how much? 2 pi into 0.53 angstrom or not. So in J main exam, sometimes they may ask to you what is the wavelength in first orbit. This is the answer 2 pi and this. Okay, that you got. Now listen everyone very carefully. If I say no, I want to talk for n equals to 2. What I want to talk? N equals to 2. So it means now my wavelength become 2 times of this one or not? Yes or no? अरे तुम लोग respond नहीं कर रहे हो. Right? If I say n equals to 2, so now lambda will become how much? 2 pi into, this is 0.53 into, because n is there, z suppose that I taken for hydrogen atom. So how much? 2 or not? Yes or no? Any doubt up to this? Sir, you will not respond. Any doubt up to
No,
this?
sir.
No doubt. Now listen everyone very carefully. It means, see everyone. It means if I say wavelength, this was in ground state. This is n equals to 2. Same thing, n equals to 3 multiply 3. N equals to 4 multiply 4. Listen everyone very carefully what is going on here. See, if I said to you, in ground state, wavelength is this much. In second state, wavelength will be what? 2 times or not? In third, n equals to 3, it will be 3 times of ground or not? If I say n equals to 4, it will be 4 times of ground or not? Yes or no? Okay, so it is just like that. It means my wavelength start increasing. It means if suppose that in ground state, our wavelength is suppose that 1 mm. Yeah, any actually it will be an angstrom. Suppose that 100 angstrom. Wavelength is 100 angstrom. So in second, it will be 200 angstrom or not? In third, it will be 300 angstrom or not? Okay, it will be keep on just like that or not? It means by number of loops, not loops, sorry. Okay, by number of wavelength. See in your figure, see that that is on the screen right now. How many number of wavelengths are there? Can anyone tell? How many number of wavelengths are there? Or I can say how many number of, okay, that one. I wavelength you can say proper word. How many number of
Three.
wavelengths are there? Three.
Three.
Okay, don't count six. This will be wavelength na. If you talk, this is complete one wavelength. This is not wavelength, it is lambda by 2. This is wavelength. Okay, so it means we are talking about which state? N equals to 1, n equals to 2, n equals to 3. Which state we are talking? अरे बोल दो ना. We are talking about which state? And n equals to 1 state, n equals to 2 state, n equals to 3 state. In this figure, in this question, it is they are talking about which state? N equals to 1, 2, 3, 4, 5. Which? Can you tell? अरे 3 यार.
Yes, sir.
अरे 3 ना यार. Why? Because suppose that in ground state loop is 1. Sorry, loop is wavelength is 1. So in second it will be 3 na. In fourth it will be, in second it will be 2. In second and third it will be 3. Just like that or not? Suppose in 1 wavelength is just like that. In n equals to 2, wavelength will be just like that, because radius also will increase, you know. Okay, so it will be just like that. 1 wavelength, okay, and this is 2 wavelength. Okay, next will be radius will increase, periphery will increase. So n equals to 3, 1, 2, 3, just like that. Okay, just like that. Any confusion up to this? Okay, so now listen, they say it can go to 3 different photons. Yes, why? Because we got here n equals to 3. So n equals to 3, how many number of photons? 3c2, how much? Now I think you know what is the meaning of 3c2 going on in your mathematics. So 3c2, how much? 3. The number of different photons, 3. Okay, but now the wavelength of this electron is how much? 6 pi r naught, where r is ground state. So how they got 6 pi r naught? Listen, see everyone, just now I told now, suppose that r in ground state is how much? 0.53 n1z1. So suppose that this is n equals to, it is suppose that r naught, this is in ground state. Okay, but if I talk n equals to 3, what it will be? Now listen everyone, so 2 pi r is this. So how much? 0.53 n square by z is equals to n lambda. N will get cancelled. Okay, so n will get cancelled. Z is 1. So how much this is? Equals to r naught, so 2 pi into r naught. They are talking n equals to 3 is equals to lambda. So lambda is equals to how much? 6 pi into r naught. Any doubt up to this? Any doubt here?
No, sir.
Conceptual. Now you will make mistake in this kind of problem. Mistake करोगे ना?
No, sir.
हाँ, करना नहीं, तो बताने कोई मतलब नहीं मिलेगा. ओके, नाउ स्टॉप है. अरे ये क्या हुआ? 1 minute. Now we'll start our regular. If you want to get write down also somewhere, so that from now onwards you're not confused. Now listen everyone. Yesterday we discussed, okay, binding energy per nucleon. We have to decide stability based upon binding energy per nucleon. Okay. So if suppose that we draw graph for this one, it is not important, but remember one thing. What I remember that I will tell. See.
Sir,
Yes.
sir, you told you will discuss that E equal to delta M into.
Acha, one more thing. Listen, yeah. Yes, at that day you just everyone get confused. Okay, regarding what? See everyone. Listen, everyone. Okay, a message that person message me. What? Listen. Suppose that at that day na, I told delta m into c square, okay, is equals to q. And when we converted delta m into AMU, they are thinking you should divide it by 1.67 to the power minus 27. But sir, you multiplied here. Okay, 1.67 to 10 power minus 27. You multiplied. It is correct or listen, it is correct actually. You have to multiply. Why? See, actually, this is you know already, but just basic thing. Okay, see, listen everyone. Suppose that this is rectangle. Okay, if I say this is side A, okay, and this side B. Okay, now in suppose that this was in meter, this was also in meter. Okay, if I said to you, what is area? So you will say area is nothing but A into B, and final answer is A meter square. Any confusion? No confusion. But now I want to change one thing. What I want to change? Here, okay, B is meter is correct. Okay, no problem. But I want every time A should be in centimeter. Are you listening or not? What I want to say? See, everyone. Suppose that A and B. Why I am saying this one? Those who did not get, sir, what you start saying area of rectangle. Okay. At that day, if you check my first class, okay, at that day, if you remember, convert, okay, we convert kilogram into AMU, we multiplied. So few students confused, sir, why you multiplied? Why you not divide it? You should divide now, sir. Okay, so why I am multiplying, that one I am discussing. Okay, now those who did not get, now you should know why I am doing these things. Okay, now listen everyone very carefully. So A into B is meter square. Okay, but if I say no, yaar, I want A should be in centimeter. Okay, therefore A should be in centimeter. Now what I will do, I know already A in meter. So suppose that A equals to 1 meter, B is equals to 2 meter. Please see everyone very carefully. A is equals to 1 meter, B is equals to 2 meter. Okay, if I say what is the area, so you will say 2 meter square. Okay, but if I said to you here, no, yaar, A should be in centimeter. Okay, A should be in centimeter, but that value should not change. Okay, what is this? Then what I can do? I will write A in centimeter. A in centimeter into 100 into B into meter square. You did not get what I did. I
Got it, sir. Got it.
Okay, I think you got what I want to say. Why I multiplied? Okay, now because suppose that I got A, suppose that in this problem. Okay, so just put here, you will get what? Same magnitude. Now I think you got. This is the reason we multiplied. Now listen, graph. At that day, what I told, binding energy per nucleon, okay, is it will tell to you stability. So if I draw graph, binding energy, no one is going to ask you graph, okay, but if you remember, it's good. Binding energy per nucleon. Everyone know what is the meaning of nucleon. Nucleon means neutron plus proton. Okay. Now see, if it is not exact actually graph, I cannot draw, but approx is correct actually. It is just like that. Okay. you will get, and this is atomic number. I can say Z. So if we draw this binding energy per nucleon, we found actually what we found. We suppose that this is okay. This is our iron Fe. Okay, Fe. So 26 Fe. So that binding energy we got how much? Approximately 8.8. Okay, mega electron volt per nucleon. Okay, per nucleon. Nucleon means everyone remember. Okay, so this we got. So it means in entire periodic table. Okay, binding energy per nucleon is highest for what? For iron. Therefore, which one is more stable? In complete in total periodic table, which one is highest stable particle? It's iron.
Iron.
I think you know also from okay from chemistry also, but so it means if we go to this side, so stability starts decreasing. If we go to this side even, so stability start decreasing, just like that. Okay, so similar thing I will okay so write down draw this graph so that I can tell more. Draw this graph. So write down also okay, iron is more stable. So in the main exam they may ask to you okay this question, which one is more stable. If you want, you can remember this value also corresponding 8.8 mega electron volt. I think completed. ना कुछ ऐसा था नहीं. Now see. Complete, and this was for Z. Okay. Now next one more graph I will draw. This is anyhow Z, and this is N. That I will say number of neutron. Okay. So in reality, suppose that this is our 45-degree line. Okay. So in this one, this is number of neutron and this is the number of proton. Okay. In this region, whatever that particles will lie, that will be higher stable. Those who will lie below or above this one, they are okay less stable. Therefore, what will happen? Those who are at higher okay are lower. Okay, those who are approximately I can say generally those who are at higher atomic number. Okay, they will try to come from this region to in that region so that they can become stable. Therefore, what happened to achieving stability? Therefore, they will convert its nucleus to other. It's like I can say, you know, from chemistry, it is radioactivity is called. Okay, generally for especially it is for higher. Okay, for lower also. Okay, those who are at lower stage, they will also try to come in this region. Okay, so in reality, in practically, how this graph will look like that I will tell. Okay, by that by share, I will share a screen. Then you will get. See everyone in your screen. See, this is approximately just like that. These are real graph. Okay, practical graph. So approx this is the stability number of neutron versus Z. So this is from SC Verma. Okay, you can see in your SC Verma also. This is that graph actually. So approximately if you draw, okay, so it is just like that. Okay. So it is just like that. You can see in your SCV. That is. See, so listen, everyone. If you want, you can write down in your language 2 to 3 lines. What to write? Those who are okay, those who lie in this region, they are high stable. Okay, you have to write, please. Those who are lie in this region, they are high stable. Okay, those who are lie beyond this region, they are less stable. Therefore, they will try to come, okay, from unstable region to stable region. Okay, in this process, some particle, okay, will emit. Okay, what some atoms will emit some other particles. Okay, this is called decay. Will you able to write? Are you listening? Will you able to write this one or not? In this
Yes,
region,
sir.
whatever atoms are lying, they are high stable. Okay, beyond this region they are less stable. Therefore these will try to come in stable region. Okay, so when they will try to come in stable region, therefore they will emit particles. Okay, this is called decay. So how many number of particles they will emit? Three: alpha, beta, gamma. You know, in radioactivity. Okay, I want to enter in that, okay, portion, but before we will discuss some other kind of things. Okay, now write down this one in your language and I will start some. Write down this one. Listen, everyone. Please, after that, right? Listen. What I want to say. I already told now. Okay, that graph I told in that one I told okay, from instability to stability. Okay, when any particle will go or atom will go, definitely it will release particle. Okay, especially those who are at higher atomic number. Okay, they will release. Generally, they are okay high unstable. Okay, therefore they are okay used to release this particle. Okay, very easily. The high unstable particle. Okay, therefore how many particles? Generally three particles: alpha, beta, gamma. Therefore, that I discussed. What is the alpha? What is the beta? What is the gamma? So alpha, everyone knows is a helium nucleus. So every time, what is the charge? Equals to how much charge? 4, because the 4 protons are there. Therefore, charge will be equals to 4e. Okay, mass equals to 4a. Sorry, 2e. Here I take 4e. It is 2e. 2e. Mass equals to 4 amu. Mass equals to how much? 4 amu. Okay. So atomic mass. Beta particles. So how many number of beta particles? 2. So beta minus beta plus. It is called electron. It is called positron. Everyone remember. Okay. I think everyone knows. Mass of electron and charge will be equals to charge same as the electron, but here will be positive charge. What is the gamma particle? What we studied till now in photons. Okay. It is energy, form of energy. Therefore, it is, I will say, as a photon. Okay. Now, after that, in chemistry, also sir told this kind of things. The gamma particle is neutral. Okay, photon only, energy. So it will without, and if it is electric field you apply in this direction, so without deviation, okay, gamma particle will go just like that. But because beta particle also charge, okay, alpha, these are the charged particles. So alpha positive charge, beta also positive charge. Therefore, they will align along the direction of electric field. But who will deviate more? So I told here acceleration on beta particle is more, because see here you are divided by 9 into 10 power minus 31. Here it is minus 27. So this become higher magnitude. Therefore, beta particle will more accelerate as compared to alpha particle. Therefore, it will deviate also more. Okay, as compared to alpha. So it is alpha particle. So same, but if this beta is negative, is what? Negative charge, so it will force will act opposite to the direction of electric field. Therefore, it will go in this direction. Okay, this up till now I told, and after that write down. Listen everyone, and after that write this. See, you know already these things actually, I think. Okay, but even though, see, what in JEE question exam they may ask this kind of questions. How? Let's see. Listen, suppose that everyone remember. Okay, one thing, but is just question they may ask. Even suppose the alpha particle is released, what is the change in atomic mass, atomic number, and atomic number and atomic mass? How by that what factor it will change? So they may ask this kind of question. So then I'm not going to solve this kind of thing. Suppose that if two alpha particles, so how many it will change? So Z minus 4, here A minus 8. You know this one, Arman? Yes, Arman.
Yes, sir.
Yes, sir.
अरे भैया ये पता बच्चों वाली बात है मतलब नर्सरी केजी वाली. This is any particle, okay, if it alpha particle will release, so by common sense what happen here, atomic number will decrease, okay, and atomic mass also mass number also will decrease. So how much, if suppose that one alpha particle release, so by what factor atomic not factor, by how much, okay, it will decrease by magnitude 2, it will decrease by 4. In JEE main exam they may ask this kind of question. Really, I'm saying, okay, they may say suppose that 4 alpha particles, okay, release. So now what is the final atomic number or atomic mass of the final, okay, product or whatever they can ask this kind of thing. Okay, so they can ask this question, but I'm not going to solve this question. In chemistry, you know, sir, given this kind of question. Okay, but now what more important thing, okay, in JEE main point of view that I want to say. See, we practically we found, okay, mass of this one and masses of this one, okay, is not equal to this. Okay, why? We found that the energy of this one, if cumulative of these two product and these are reactant, is not equal, and we found the energy of product was more as compared to energy of, okay, this product, this energy of reactant is more as compared to this product actually. Okay, so it means what happened, it means 100% when energy release means what, Q is equals to delta M into C square. It means mass is also reduced when energy is reduced. Okay, therefore how much it reduced, that I want to say you. Okay, so delta M is equals to how much? Acha, one more thing, every time in reaction, okay, in this reaction, who will take part? Okay, nucleus will take part. Okay, therefore we will worry about more on nucleus, not as a total particle. So therefore we will write ki what is the change in the masses of nucleus, how much it is changed. So mx minus my plus m alpha, these are the product, this is the reactant. So this is, we got delta M. So with the, when we got delta M, so with the help of this one, Q is equals to delta M into, okay, by that with C square, which we already got one, okay, that formula. So 931.5 mega electron volt. By that way, we can find how much energy will release okay, when this reaction will take place. Okay, so how they will ask question, that I will discuss, but first you should know. Acha, this till now I said to you ki, okay, this derivation is not important for you, but please you should know ki how I am writing these things here. Therefore, practice. Okay, and in exam they may ask numerical based problems on these things. Okay, how they will ask that anyhow I will discuss. Therefore, please see. So this was the mass of nucleus X. This is the Y. This is the alpha. So nucleus means what? If you remove mass of electron, so this will become nucleus of X. If we here also same thing, but Y also. If you remove mass of electron, so this will become nucleus. If you remove alpha also, mass of electron, this will become nucleus. So if we solve here, so if you see here minus, okay, if here become minus minus become one more minus, okay, this minus is there, so this is ZME, okay, and this if you see this become plus, this ZME will get cancelled, this 2ME will get cancelled, so final what we get, mx minus my plus m alpha. But this you got in this equation, but not always in all equation is supposed if nucleus is mx minus my plus m alpha, so here also I will get same. Okay, no, in this particular equation we got it like that, but in some cases today if possible I will discuss some cases, okay, it may not cancel. Are you getting or not what I want to say?
Yes, sir.
Okay, and one more thing I want to say. Why I am saying this one? Okay, because in question paper, okay, and we have to check which masses they given. Okay, suppose that they given mass of nucleus, so we have to use delta for finding delta m this equation. Okay, so today if possible we will send you questions. Okay, and this if in question paper they given masses of atoms, so you have to write this equation. Okay, anyhow, in this it is a similar, but next I will tell beta plus, beta minus. There you will see it is may not cancel. Okay, therefore, how to write this delta m, that you should know. Okay, and based upon we can find q also. Acha, once we suppose that we got delta m. Okay, when we will solve numerical problem at that time, you will become more confident in how they will give information regarding delta m. Don't worry, very easy. Okay, so once suppose that I got q, so this amount of q energy will release, but where it will go? Okay, that energy will go, okay, in the form of, okay, kinetic energy of this one and this one. Are you getting on what I want to say? So because energy decreases, but whatever energy decreases, so with that energy where it will go, that will give, okay, to give kinetic energy to alpha particle and y particle. So what will be the kinetic energy for alpha particle and y particle after this reaction? In the main exam they ask this question to you out. Okay, so how to find that I will discuss. Okay, if you did not wrote, therefore write down fast. Write down and it's completed. Please take out. Listen, everyone, please listen after that, right? See, listen, what I told to you, okay? See, because whatever energy will release, okay, where it will go? So then that will go to give kinetic energy to y particle as well as alpha particle. Okay, so in JEE exam, they may ask you what is the kinetic energy for y particle, what is the kinetic energy for alpha particle. So please, after my class, do it by okay yourself once again. Okay, I think I can say 2 to 3 times. Why? Because you have to drive. If remember, it's good. Okay, if you want to get remember also this expression and this expression, because next I will tell for beta particle, next time beta plus, beta minus. Okay, therefore one expression you may get from there also. But if any student know ki how to drive this one, you can drive an exam hall is hypothetically forward. Okay, therefore 2 to 3 times today only practice. But very easy. Okay, so everyone remember ki it will go kinetic energy. Okay, it will give kinetic energy to y particle as well as alpha particle, and everyone know ki because no force was acting. Okay, net force was zero. Okay, interaction. Okay, not force. So net force will be zero. Okay, so what will happen if net force is zero? So linear momentum will be conserved or not? Yes, linear momentum will be conserved. So kinetic energy is equals to p square by 2m. So p is equals to what? Root 2k by m, and this is constant. It means for this is for y and this is for alpha is fixed. Anyhow, this should be the same place. Okay, because we are worried about a scalar quantity, kinetic energy. Therefore, you're not worried, sir, why you taken this side. Okay, in reality, this momentum P initial is equals to P final. So initial momentum for that x was zero, but final is Py plus P alpha. It should be just like that because we are worried about a scalar quantity, kinetic energy. Therefore, we take only magnitude. Therefore, I wrote Py is equals to P alpha. Therefore, don't confuse with that way. Okay. Now listen. Here we got. So after that, kinetic energy here, kinetic energy into mass of y. Okay, into kinetic energy alpha into mass of alpha. And after that, what the mass of y mass 1 minute. Now see the disturbance. Now see, so mass of y is how much? A minus 4. How? Array reaction. This is was x. So after that, this will come convert into y. So this will become z minus 2, a minus 4, and this was 2 he 4. So this mass is 4 mu. This mass is a minus 4 mu. Okay. So this we got and put these values. Okay, this everyone know. If you put this value, kinetic energy of alpha particle, put here. How much? Kinetic energy of y into my by alpha. So from here you will get kinetic energy of y. Okay, and if you put here again, so you'll get kinetic energy of alpha a minus 4 by a into p. If you remember, it's good. Otherwise, you can forward also. But remember this derivation. Okay, remember, and please again I'm saying because okay, very important. They may ask this question from there. Now up to this, I think over. Okay. Now next I will write down this one if you did not wrote. Completed. Don't write this. Don't write this. When I will say, then I'll write. Up to now, stop. Otherwise, you will think, sir, what is this? Completed. बोल दिया करो, तुम लोग बोलते नहीं है यार.
Yes, sir.
Completed,
Say
sir.
na this Pragati Maidan. We are sitting just like that. Now listen, everyone. Suppose that we got kinetic energy of y and kinetic energy of alpha. Okay. Now, if we take this alpha particle and everyone know this has positive charge, helium nucleus, positive charge. Therefore, what will happen? This alpha particle. See, therefore, this alpha particle, if it pass through a magnetic field, okay. Therefore, what happened? Because we have seen, we know everyone remember R equals to mv upon qv. Is there any class you have, other class right now? Is there
No,
any other
sir.
class?
No, sir.
This is just now start left. Please don't leave class right now. R equals to how much? mv upon qv. So everyone remember 2 kinetic energy of alpha particle, m alpha particle upon qv in terms of kinetic energy. Now what you have to write, whatever I am saying right now in your language, 2 to 3 lines you have to write this. Okay. What, suppose that here if we calculate, we got, suppose the radius 5 mm. Suppose that we got 5 mm, 5 centimeter, whatever. So it means every particle should follow this path now. It means from this point, if we send 100 number of particles, so at this point we should get 100 number of particles now. Yes or no?
Yes, sir.
So that if we send here 100 number of particles, so at this point how much we should get? 100 number of particles. Is it reality or not? We should get. But what happened? Here when we send 100 number of particles, so in back, suppose that we are getting only 5 particles on the same train. Are you getting what I want to say? Because in reality here it should be 100, but in reality I am getting 5 only. But where others will go? Therefore, others will go means it means they did not reach to this position. It means something happened in radius of curvature of this path. Okay, what will happen here? Q fix, B fix. Okay, mass is fixed. Okay, it means 2 fix. So somewhere problem is in kinetic energy. Are you getting what I want to say? What is problem? That I will discuss. Okay, please see. Here we send 100 number of particles, but in back we are not getting 100 number of particles. We are getting very, very less. How much I am getting? Suppose that I am getting 5 number of particles. So it means where other will go. So other will go. Okay, so they will follow some different path. Here, okay, here. It means then we be confused. Why they start following different paths? Okay, because here each and everything fixed, mass fixed, B fixed, Q fixed, 2 fixed. Therefore, we realize there is some problem in kinetic energy. Okay, why it is some problem in kinetic energy? Because okay, this during this reaction, okay, some particle may excited. Suppose that Y, okay, whatever we got, it may go to at excited state. Okay, so when it will come to ground state, it will release energy in the form of photon. That I will say gamma. What I will say? Gamma. Are you getting or not? How? See, don't worry. Again, I will tell you. Okay, don't worry. Please listen only. You have to write. If we send here, we did not get an exact number of particles. We will get less particles. Okay. So when we will, you didn't start leaving this class. What happened? जरा सा भी 1 घंटे से ऊपर हुआ सब भागने लगता है. I don't know why. See, so here suppose that I am sending 100. So here how much I am getting? Only 5. So where other will go? They will follow different paths. Okay, why? Because kinetic energy some other particles will decrease. How it will decrease? Please see. Suppose that we will see here. See, it was X. Okay, ZA. Now what will happen? This. Okay, during this reaction, this is Z minus 2 and this is A minus 4. This will go to excited state. Okay, and this is 2He4. So when this will go to excited, we star means will go to excited state. When it will go to excited state, when it will come to ground state, it will release energy. Okay, what it will release energy? Suppose that it will release in the form of photon. Okay, a minus 4, okay, plus gamma. Okay, so plus 2He4. Okay, so what is the gamma? It is nothing but photon energy. Okay, therefore what will happen here? If I write exact equation, z ax, only 2 minutes, please don't leave, only 2 minutes. Okay, this is y z minus 2, and this is a minus 4, 2He4 plus gamma. It means now it should have total energy should go to y and He, but now some other energy is going in the form of gamma photon. Okay, therefore resultant kinetic energy will decrease. Therefore if I say to you, okay, now write net kinetic energy for y. So how much you will write? 4 by a into q minus, okay, energy of photon. You can write energy of gamma photon, energy of gamma. So now net energy will decrease or not? When net energy will decrease, what happens? They will not come the same path, so they will come different paths. Any confusion? Any confusion? Bol do.
No, sir.
Okay, so same thing, it is kinetic energy for y. I think you wrote for alpha. So write down, after doing this, write down this one also. For alpha also, kinetic energy will become not this. This will become Q minus energy of photon. Energy of photon or energy of gamma. Okay, gamma photon, you can write this like that. So now net energy will decrease. Therefore, okay, they will not come at original path. So this is the net. So, sir, you may think, sir, confused. You may confuse, sir, which one we have to apply? Either this one or that one. So based upon question paper, if they are talking about energy of photon, so write down this equation. If they are not, they are saying no photons emitted. Therefore, you have to write previous equation only. Okay, now write down this one. After this, write down in row language 2 to 3 lines, please. It will be helpful to you. 100, so 100 will not come. Okay, suppose that 5 will come. So where it will go? So that, okay, they will follow different path. Why they will follow different path? Because energy will decrease. Why energy will decrease? Because, okay, it may go to excited state. When it come to ground state, okay, so it will release some energy, photon. Okay, and after that, its final energy will decrease. You know what? This is the reason, okay, I don't like chemistry subject. Okay, why? See here, okay, this is the practical things we people, okay, decided. By saying this one, na, this is, we cannot accept conceptually actually. Is it reality going on? Okay, therefore I don't like this chemistry. Okay, but I know you people like it more than physics, but okay, because we cannot answer कैसे excited में चला गया, क्या जरूरत था उसको जाने में, वो सारी चीजें ठीक है. Now write down this one. Okay, and we will discuss, okay, problems tomorrow. Okay, if you want, you can leave also if you completed, but write down 2 to 3 lines.